Alright, people, welcome back to 30 Days of Solidity. I am Sneha from the Web3 Compass, and this is day 21 of 30 Days of Building with Solidity. Up until now, we've been learning how smart contracts work under the hood. We made our own token, logged up, dealt with access control, ownership transfer, and even learned how to protect our contracts from shady attacks. But today is different because we're finally stepping into that part of Solidity where the stuff you built has actual real world use. And we're starting off with something very simple but yet very popular, which is the NFTs. Now, for everyone who has stumbled upon this video randomly and you don't know what this campaign is about, you can head over to web3compass.xyz, check all our tweets, all our posts from community people on LinkedIn, and you would know that we are shipping really hard. We've been building for the past 20 days straight. No days missed. Okay. So now you go to the website. This is where we have all the information for everyday challenge. And today is day 21 where we talk about simple NFT, create your own digital collectibles. You will learn how to make unique digital items by implementing the ERC 721 standard and storing metadata. We've already talked about creating your own tokens, which was ERC 20 standard. I don't remember which day was it when we talked about it. So you can go on our YouTube channel, check out all our previous videos, and then see which one did we actually talk about. Which day did we talk about it? Okay. So now let's head over to Remix real quick. Oops, I've not closed yesterday's files. Okay. Start to chuck it. Great. And now, okay. Before we start building, actually, now how many of you are aware of what is an NFT? Okay. A lot of things that NFTs are just monkey pictures or internet flexes, and under all of the hype, what we want to tell you is NFTs are about digital ownership. And the key to understanding them is this one weird sounding word, which is non-fungible. Now, NFT stands for non-fungible token. Let's break that down. A token is just a digital thing on a blockchain. Fungible means interchangeable like money. So $1 is always worth $1, no matter where it came from. Non-fungible means it's not interchangeable. It's unique, one of a kind. So let's say your friend has a pen. Cool, it's just a regular pen. You use it, lose it, whatever. Now imagine your grandfather gives you a fountain pen he has had since the 1940s. It's old, engraved, and has a story behind it. Technically, both are just pens, but are they equal? No way. The one from your grandpa is non-fungible. It has a sentimental value, a history, a uniqueness, and no other pens like that exist out there, right? So you wouldn't just swap it for a random pen from a stationery shop. Even if you get a pen that looks exactly the same, you wouldn't swap it. So this is exactly how NFTs work. They're digital items that aren't all the same. Each one has its own ID, own data, its own meaning. Again, lot of metadata stuff. And even if they are part of the same collection, NFT #1 might be totally different from NFT number 2000. Different image, different stats, different story to talk about. Okay. So how is this different from the ERC that we built before, right? So the ERC20 token that we made before, that was a fungible token. It was like making our own digital currency. If you have 10 of it and I have 10 of it, we've got the same thing. Tokens are equal and interchangeable, but NFTs, which is built using ERC 721 standard, again, ERC stands for Ethereum Request for Commons, are totally different. Each token has its own identity, own number, own meaning, and you can't swap them 1:1 because each one could represent something completely different, and they are more than just art. This is the part that pisses most of the people, that NFTs aren't just about artworks or collectibles. They are a way to represent ownership, of literally anything in a digital form. Let's break down a real example. Event tickets. NFT can be a ticket to a concert, a workshop, or a festival. No paper, no screenshot. Just scan it from your wallet and you're in. It could be an in-game stuff, that rare skin, that sword or house you grinded for. It's an NFT. You own it, not the game company. You can sell it, rent it, even take it into other games. Okay. Property are legal docs. In the future, your house deed could be an NFT. It would live on chain, be super hard to fake and easy to transfer without 20 layers of paperwork that we actually need in the real world scenario. And certificates as proof. NFTs can be used as digital certificates, whatever stuff it is, okay? It's your tickets, collectibles, IDs, credentials, whatever it is. Everything can be NFT, and they could finally be made real in the digital space, okay? So what we're going to do today is we'll keep it simple, but we're going to build our very first NFT contract from scratch. No OpenZeppelin, no copy pasting, just raw Solidity. So you understand what's actually going on behind the scenes. It will follow the ERC 721 standard, like I mentioned, and which is like, again, a rule book for NFTs on Ethereum. By the end of this, you will have created a mintable NFT, the kind you could connect to a game, a gallery, or even your own mini marketplace. So let's just get started. Okay, now we'll deal with a lot of interfaces. We would give our NFT collection a name, a symbol, which will help you mint new NFTs with custom metadata, again, image, description, track who owns it, keeps track of how many NFT each person owns, let owners approve others to transfer their NFT, and of course, handles transfers between users. So let's just get started. The interface one is gonna be a little lengthy than the usual ones, but yeah, we have to do it, right? So just get yourself ready. Oops, what happened to my, yeah. So we are saying NFT. Done. Okay, great. Oh, it's zoomed in already. Great. So, yes. We will copy this, close this so that we don't get confused. And we are saying, okay, the first thing that we're going to write is to write an interface. Now, this is going to be the ERC 721 interface, which defines all the mandatory functions and events an NFT contract must implement to be called ERC 721 compliant. It's like saying, hey, Ethereum, my contract is an NFT contract, and here are the things I promise to support. Events like transfer, approval, tell the blockchain and front ends that when NFTs moves or get approved, and functions handle ownership, approvals, and transferring tokens and all of it. Okay. So let's just get started. Okay. Interface IERC 721. Okay, great. We're saying before we think of, we know that the interface is going to be an implementation. So there could be events, there could be functions and all of that. So let's just get started. We're saying, okay, event, what could that be? Okay, we know that there can be a transfer. There would be a transfer where we say address indexed from, and then address indexed to, right? And then we're saying uint 256 indexed token ID. Okay, that's it. Great. Then we're saying event approval. Okay. We're saying address indexed owner, who is the owner that we have to seek the approval from. Then we're saying address indexed, who am I giving the approval to, right? So approved. Then we're saying uint 256 indexed token ID. Again, very predictable. Then we're saying event approval for all. Okay, now we'll see how is it going to be different. So this one is going to talk about address, indexed owner, and then the other one is going to be address, indexed operator. Okay. And again, because we're doing it on a large scale, and then we're saying bool approved. Okay. Is it approved? Is it not? Okay. Now, once we've written these events, we will head off to functions. Okay. Now what happens here is that what do you think can be the possible functions here? Okay. We will say, okay. Yeah, it says function balance of address owner, external view returns you int 256. Then we are saying function owner of. So this is going to be same as per what the 721 template or blueprint looks like. So that is all that we are, talking about. Then we're saying function approve address to address uint 256 token ID, because we know who the owner is, so it's fine. Saying external. Okay, great. Then we're saying function get approved, obviously. So you can just refer to any NFT thingy and NFT implementation, and then just be like, oh, okay, this works. Okay. External view returns address. So as of now, we've written balance of, owner of. Balance is taking address of the owner. It's external view returns you in 256. Owner of, again, token ID, external view returns address. And then function approve. Okay, same. Great. Now, the other functions that we're going to write is function set approval for all, and we're saying we will take the address, oh my god, address of the operator, and then we say bool approved. Okay, great. And this will also be external. Okay, then we're saying function is approved for all, and we're saying address owner, address operator. Okay, address is approved for all, address owner, address operator, and then we're saying, hey, it's gonna be external view returns. And then we're saying it has to be bool, because come on, the function itself is saying, is it approved for all, true or false, right? So great. Then we're saying function transfer from, right? So we're saying, come on. Okay. So we're saying there would be an address from, there would be an address to, then there would be uint 256 token ID, right? And we're saying this is going to be external. Okay. Now, it also talks about function safe transfer. Now, when we look into all these explanations of, or when we implement all of these functions, we're going to write about it. As of now, you just have to remember that this is the blueprint. This is how, these are the mandatory functions that has to be there. And yeah, great. External. Okay. So we're saying, okay, function transfer from, safe transfer from. Now, there's another thing. There's another function safe transfer from, and it takes address from, address to, uint 256 token ID, and bytes called data, and it's external. Now, it looks similar, but then we will see that what is the difference that we are going to, implement here. Okay. So this is the YASI 721 events. Now, interface, and we've implemented events like transfer approval, blah, blah, blah. There is one interface, which is ERC721 receiver, which we will implement again. This interface is used to safely send NFTs to contracts. Without it, if you try to transfer an NFT to a smart contract that can't handle it, the NFT might just get stuck. So we can check that the receiving contract knows what to do with that, NFT. So we will write that as well. Okay. We're saying interface IERC721 receiver. Receiver. Oh. Receiver. Great. Finally. Okay. So we're saying function on ERC721 received. Right? This is how. What have I done? Function on ERC721. Okay. Received. Great. Finally. So we are taking the address of the operator. Then we are taking the address. We're taking the address from. Then we're taking uint256. Token ID, and we are saying bytes call data, and we're saying it's going to be external, and then it will return something of the value bytes 4. Now we'll see what it does, right? Right now, this is all that we have. Now is when we start implementing the contract. So we say, hey, contract SimpleNFT is IERC721. Okay. So I will just delete this one and say, okay, IERC721. Oh, what just happened? Yeah. Oh, yeah. Thanks. Great. Okay. So now this could be marked as abstract. Yeah, that's just because of the implementation. Now what we do is for the NFT, we just need a name and a symbol, and then probably a private state variable for, token ID counter. That's it. So we're saying string public name, and we are saying string public symbol. Okay, great. And uint256 private. Oh, not here. Private, and we're saying token ID counter is equals to 1. Okay, now this is clear. We don't need a lot of variables here. Now mappings. Okay, so for every owner, okay, there would be a mapping with a number value. Now, why a number value is because who owns token hash X, right? But wait, before I get into the mappings, I hope all of this is clear, right? Like, for everyone, I know that name and symbol might be clear for you, but when it comes to token ID counter, some of you might be confused. So just to tell you that NFTs need to be unique, right? So we assign them IDs like collectible cards, which are numbered 1, 2, 3, and so on. This variable helps us keep track of the next available token ID to mint. So we start from 1 instead of 0 just to keep things human readable and less error prone. And every time we mint a new NFT, we use the current token ID counter and then increase it by 1 for the next mint. Okay, so I hope that's clear. Now we'll go to mapping, where we're saying, okay, the first mapping would be a uint256 with an address, okay, and we are calling it as private, and we say, hey, that is going to be owners. Why? Because who owns token hash X, right? Because we use this to store address of the person who owns a given token ID, right? So if owners 10, right, is equals to blah, 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 an address 0x ABCDEF, whatever, it means that the token number 10 is owned by that address. Okay, so no owner, no token. Okay. Now, the other mapping is going to be between an address and then again a uint 256, which would be private, and we say balances. Okay, now what happens is this one's the opposite of the above. Instead of asking who owns token number X, this asks how many tokens does Alice own. So we're tracking balances here, how many total NFTs an address owns. So if balances for an address 0xabc is 3, that means that the person owns 3 NFT from this contract. This helps us implement the balance of function in the interface. Okay. Now, the other thing is mapping a uint 256 with an address again, and we're saying a private underscore token approvals. Okay, now what happens? This is going to be the security checkpoint. NFTs can be approved to be transferred by someone else. For example, if you want OpenSea to sell your NFT on your behalf, you need to approve them. So this mapping will track, hey, token approval for number 12 is equals to 0x an address of OpenSea, which means that the address of OpenSea is approved to transfer token number 12. That is why a uint 256 to an address. Think of it like giving someone temporary permission to hand over your card collection to a buyer. Okay. So the next mapping is a dual mapping, which says mapping address with another mapping of an address to a bool. Now what we're doing is, AI knows. Okay. We're looking at private. You're saying private operator approvals. This means it's like a broader version of the previous one that we're talking. Here we're saying, I trust this address to manage all of my NFTs, not just once, right? Because we're giving it all. So for example, operator approvals, Sneha, Setu equals to true. That means Setu is allowed to move any NFT owned by Sneha. This is handy for marketplaces, rental systems, or delegating rights to another wallet. Okay, now let's look into mapping uint 256 to a string, and we're saying private token URIs. Now, the fun part is that this is where the NFT magic lives, okay? This mapping stores the metadata URL for each version. So each token might have an image, a description, maybe even a 3D model. So this URI can point to something like https mynfthost.com metadata 42.json blah blah blah, which contains again description like name, image, and all of that. So this is what makes NFTs more than just numbers. They become characters, artworks, music, anything that you want them to represent. Okay, now it's time that we write the constructor. Okay, I like writing constructor. You just have to do it once. Sake. So you're saying there would be string memory name, and then there would be string memory on string memory symbol, and we've already fine, whatever. And then we're saying, okay, name is going to be underscore name, and symbol is equals to underscore symbol. Now you know what happens here, right? I don't have to explain this. Okay. So great. Great. Okay, now it's time we jump into, functions. We'll write the cute ones first. Function balance of, okay, and we're saying address of the owner, okay, public view override returns UNT 256, okay. Now, what do we do here? We check if the owner's address, which we've done before, is not equals to address 0. If it is not, great. If it is, then bro, you need to tell that this is a invalid /0 address we are talking about. And the next thing we have to do is return balances of the owner. Okay. Now for all those who are thinking like we have the same thing implemented in the interface, and that is why the override part comes here. Now, okay, let's on to this is pretty simple. You just want to check the balance, so you're checking a required condition, and yeah, just move on, right? Now I will say, okay, we're saying function owner of. Okay, so we're saying UNT 256 token ID. Now the function itself tells you that, hey, I want to check who is the owner of this particular token, right? So we're saying returns address, great. And we're saying, okay, address owner is equals to, now it will check the mapping, okay, owner's token ID, great. And then it also checks if this owner is not equals to address 0, because if it is, then it's a problem because it says invalid /0 address, right? Or maybe we can write something else where we say, hey, token does not exist, right? And then we're saying, okay, now just return the owner, right? Because we fetched it from the mapping ready. Great. Okay, now what next? Now we're going to talk about approvals. So we write a function approve, okay, which says function approve, okay, address to, and then we are saying UNT 256 token ID. Who are we seeking the approval for, right? But wait. Okay, so we're saying address owner is equals to owner. We'll just call this function, okay, instead of checking it from the mapping. And we're saying an owner of, and then require function will check that 2 is not equals to the owner's address, because if it is, then it's already owner, right? Great. Okay. And then we say, hey, another thing is require message.sender is equals to owner. Okay. And another is an or operator, and you check is approved for all. And we're saying owner comma message dot sender. So this is basically like, if this is true, great, otherwise not author text. Okay, and then we say token approvals for this particular token ID is given to 2, right? And we're saying emit approval and what? Owner, and then approved 2, and we're saying token ID. Great. Now this function is not yet implemented. It says like the approve function is saying, hey, I'm giving this specific person permission to transfer the specific token. It doesn't transfer ownership. It just hands over the keys temporarily. So then we'll see what happens here. Okay. So it says, the required condition that we're talking about for message.sender equals to owner, it says you can only approve someone if you are the owner, or if you have been approved by the owner to manage all their tokens via set approve for all. Okay, basically owner can approve someone, an operator who's someone who's pre-approved can approve someone. So a random wallet cannot. So this ensures that only authorized users can assign token specific permissions. Okay. And then it check if all the checks are passed, we go ahead, save the approval. That means, token approvals for this 1, 2, 3 or, whatever token number is transferred to address, which is stored in address 2. And then this gets stored in the token approval mapping, and then an event is emitted where we're saying emit approval, a little shout out to the outside world that, hey, you know what? The approval has been given from the owner to this particular address for this particular token. Now, this event is super important for platforms like OpenSea or Etherscan because it helps them know who owns that, who allowed to move it. Okay. So all of it is just very transparent. Okay. Now I know that we've not implemented this, but we know how the structure is going to look like because it says owner, operator, external view, returns, etc. So we will just quickly go and implement this particular function. We are saying function is approved for all. We're saying address of the owner and then address of the operator, right? And then we say, hey, public view returns, because this is going to be just a simple approval function. And we say, can you just return operator approvals, owner and operator, right? So we just return the operator approvals, owner and operator. So that's a mapping that's already there, right? I will just make it a little bit better in terms of design. So this entire thing will just continue to happen until we actually implement the entire thing. So we have now implement is approved for all. There are two other functions around the same thing. One is get approved, one is set approval for all. So this is how a function get approved looks like. You're saying, hey, this particular token ID, public view override returns address, because you want to get it approved for a certain token. So we say require, instead of token approvals, we're saying owners, right? For that particular token ID not equals to address 0, because again, not invalid or 0 approval. I mean, I feel that it's better to write that token does not exist. Token does not exist, and then you just return token approvals for that token ID. That simple. So you can just figure it out. Okay. Now, other one is a set approval for all. So here we're going to deal with an operator. Again, it could be OpenSea, Rarible, any kind of marketplace, etc. So it says address operator, bool approved. We make it public. We're saying override. And what do we want to return? We've not decided yet. Right. Okay. So again, a few checks. Operator should not be equals to message sender. Require operator is not equals to message dot sender. Great. Otherwise, it will say, hey, you're self-approving. Come on. Right? And then it says operator approvals, which is again a dual mapping. So we're saying message dot sender with an operator. And you just say it's approved. Right? and then just emit approval for all, message.sender, operator, or approved. Now, let's check this mapping. How does it look like? So this is the operator approval. So we had an address, we had another address, and then we had a bool value, right? So that's what we're doing here. We're saying message.sender an address, operator an address, and then set it as approved, which is a bool value, true or false. And then you just emit that particular event, right? Very simple explanation. There's nothing that you would not understand here. Now, let's get to implementing transfer functions. And this one's going to be an internal transfer. I'll tell you what that means. Okay, so let's say with internal transfer, we're writing it with an underscore. Okay, we're saying address from address to UN256 token ID, and we're saying, okay, internal virtual. We're going to implement two similar kinds, but just watch. Okay, we're saying require owner of. We're calling that function, right? And we're saying, parenthesis. Token ID, right, is equals to from. Okay, you have to check that. If yes, great. Otherwise, not owner. And we're saying require the to address is not equals to address 0. Great. Otherwise, it says 0 address. Okay, great. These two conditions are checked. Now what happens is you go for balances and you say from, because we're transferring it, right? So we're saying minus equals to 1. Then we're saying balances 2 plus equals to 1. Great. Now we're saying owner's token ID needs to be set to 2 because we have to update the mapping. And then we say, what are these? What are these? No. This is cool. This is fine. And then we're saying, hey, delete token approvals and token ID. Now, what did we just do? Right? So we're saying that, hey, this transfer function, which is an internal function again, is the core function that handles the actual movement of NFT from one wallet to another, as you can see. But here's the thing. The underscore transfer is not meant to be called directly by users. Instead, it acts as a helper, a reusable internal tool that other functions like transfer from and safe transfer from rely on under the hood. Now, we have implemented something similar in one of our previous contracts where we were doing an internal function so that there's no repetition of logic, but then if an update is required or whatsoever, right? So we're saying the transfer from and the safe transfer from rely on under the hood on underscore transfer. Now a little bit can be different. So we did this in ERC20 as well. Okay. Now, so whenever someone calls those public transfer function, this little guy right here is doing the real job. Now let's understand if there's something that you've not really understood. The conditions are definitely clear for you. The from address is losing an NFT, so we decrease the balance by 1. The to is getting an NFT, so we increase the balance by 1. We're changing the ownership because we need to reassign the token ID to the new owner, and this is the most critical step again because the ownership record gets updated. Now there's something is delete token approval. So if someone had previously approved to transfer this token, we remove that approval. Why? Because there's a new owner now. So after all, once the token has a new owner, now they should decide who, if anyone, gets permission next, right? And then we emit the transfer event, again, an official signal to the blockchain that, hey, token 123 just moved from Sneha to Setu. This event is very important by the ERC 721 standard and is what makes public UIs stay in sync with what is happening behind the scenes in the blockchain state, right? Now, why was this function internal again? Great question. If you're thinking about it, we mark this function as internal because it's not safe for end users to call it directly. It doesn't perform permission checks like, is the caller approved to transfer this token? It assumes these checks have already happened in the outer function, like transfer from or safe transfer from. So instead of repeating this transfer logic everywhere, we write it once and call it safely from other functions after all permissions are verified and from the functions that need this kind of logic. Okay. Now we're going to write another internal function, which is delete this. AI wrote this. I did not. Now we're again going to write an internal function which says function safe transfer. Okay. Now again, for private functions or internal functions, we are writing with an underscore. We're saying address from address to, and then UND 56 token ID, and then this was the one which has bytes, memory, call, data, and we're saying this is internal and virtual. Oh, call data. Oh, correct. Now what does this do? It will just use the internal transfer function from should work token ID, and then we say, hey, we need to require. This is where we use that particular check on ERC 721 received interface that we implemented. And we're saying from to token ID and data. If yes, like if everything's in place, it's good. Otherwise, this is not ERC 721 receive. Just written it horribly. Sorry, guys. Okay, so we're saying what? Now, again, this function, yeah. So once you're writing the safe transfer function, the idea behind this is that it will act like the internal function transfer, but with extra safety armor. So it does everything that underscore transfer does, like updating balances, ownership, clearing approvals, blah, blah, blah. But then adds a very crucial check afterwards. So, hey, are we sending this NFT to a smart contract? If yes, can it actually receive NFTs? Because here is the thing. If you actually send an NFT to a contract who doesn't know how to handle NFTs, it will just get there stuck forever, right? So then we will have to implement something, just like we did, like we wrote an interface IRC 721 receiver. So maybe we will have to write a required condition saying, check on ERC 721 receiver with blah, blah, blah. But then, hey, we haven't really implemented that yet, right? So we will implement a similar function. So it will work fine if 2 is a normal wallet. It will work extra safe when 2 is a smart contract, and it will revert if the contract does not support ERC 721, right? So let's just first quickly write that check. Same function check on ERC 721 received every time received. So we're saying address from address to token ID by its memory data. And we're saying this is private and it returns what? A bool, if it is like apt or not, right? So we say if 2.code.length is greater than 0, right? Try IERC 721. dot on ERC received a message dot sender from token ID data. It says returns bytes retro. Okay. Now, what is happening? I know too many competitors. Too many lines, too many confusions. So we're saying again, it will act as a safety check in the underscore safe transfer. Are we sending this NFT to a smart contract that knows how to handle it? So let's just go understand what it is doing. So it says if 2.code.length is greater than 0, that means is the recipient a smart contract? Wallet addresses have no code but contracts too. So the 2.code.length greater than 0, then yeah, we're talking to a smart contract. So let's implement the next line, which says when we try to call the function that a smart contract is supposed to implement if it wants to safely receive NFTs. This is like knocking a door on the asking, do you know what to do with these NFTs? If the contract returns the expected value, which is a specific selector, all is good, transfer successful. The catch failure says if the call fails, that is the contract does not implement on ERC 721 received or throws an error, then we return false. This causes underscore safe transfer to revert the entire transaction, protecting the NFT from being lost. And then we just say return true. Okay. But let's just implement, right? So we're saying, okay, great. Now, return value is going to be IRC 721. 721, a receiver on ERC 721 received dot selector great. Otherwise, catch says return false. That's it. Okay. And then we're saying, oh, they're going to be, did we not write it here? Right? And then we're saying, okay, this is done. And then you return. Okay. So you've understood now this is what we had to implement here. So we're saying check on ERC 721 received, and what are we passing here in the from to token ID data? Great. Otherwise, we're saying it is not ERC 721 receiver. Okay, I'm not changing this. Enough. Just okay, let's see what is really wrong here. Okay. Now, the other thing that we have to implement is function is approve or owner. Okay. So this is like a gatekeeper function. Before we allow anyone to move a token, we ask this simple question. Is the caller allowed to move this token? So what we'll do here is address spender uint token ID. Instead of public, it should actually be internal. Okay, and view returns and returns what? A bool value. Okay, we will check a few things. Address owner is the person owner of, okay, that particular token ID. Great. Then we say return spender equals to owner. Okay, and then we say no. Then we say or get approved. Was it approved, right? the particular token ID was approved for this particular spender. Okay. And then we again check another condition is approved for all, because then, we do not have to separately check. Any of these could be just fine. Right? Great. So this will return like a bool value. So we're saying spender is owner. So if the person calling this is the actual owner of the token, great. Otherwise, the token owner gave specific person this permission to move this one token, great. Or the owner of this person said that this person can manage all my tokens. If any of these checks return true, then the caller is authorized to proceed. Okay, so we've done these basic implementations, and now what have we not implemented? Okay, we've not implemented functions like transfer from, where we were going to use the internal function. So we're saying transfer from, again, address from to 6 token ID public override same. Okay, so require is approved. Okay, that the previous function that we just implemented is going to, we're going to call that, and we're saying message.sender token ID. We check all the 3 conditions, and we're saying, oh, if it is, great, otherwise it's not authorized. If it is authorized, then we just say, what happened? Oh, sorry. Okay. We say that underscore transfer from to ID. Great. That's how we're calling, right? So it uses is approved or owner, but what we did mistake here is that it was right the first instance. This is an internal function, so we will write it like this. Okay, great. So now we've written even the basic transfer function. Now there would be a safe transfer from, which is the basic version without data. Safe transfer from, we're saying address from address to uint token ID public override, and then we're saying, okay, then we need to check. No, we don't, which is saying safe transfer from, and this is from to token ID. Great. Now what happens here is that this is a simplified version of safe transfer. Think of it as a shortcut. When you don't want to include any data, just call this one. All this does is delegate to the next version, the one with bytes, memory, and data, passing in an empty data payload. This is useful for 99% of the transfers, like when a user is simply sending an NFT from one wallet to another. Now we're simply going to implement the safe transfer from. Okay, come on, and just copy this. Okay, but this will have some different thing. Let me just write it. Okay. So it says address from, address to, uint256 token ID, as well as bytes, memory, data. And it says public override, safe transfer. Okay, this is going to be underscore safe transfer, not from, Okay. And here we will have data. Okay. Now there's another thing which is left, which is required. Here is because we are, like I said in the previous one, that are we going to check the condition here? And I said, oh no, let's just implement it. That's because we're not really doing any data check and all of that, and that gets routed here. So we're saying is approved owner or owner, whatever, message sender, token ID, not authorized. Okay, so here what we're doing is we're implementing this particular safe transfer, which was an internal function. The check is happening, right? So the previous one was without data. This is the real safe transfer from function. This one does the actual work. Now, again, with is approved or owner, we are ensuring that the caller is allowed to move this NFT, who's allowed the owner of the token, someone who has been approved to transfer this specific token, blah, 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 perform the safe transfer. Now what we have left is two functions, which is one is mint and the other is token URI. So we'll just quickly write it. Oh my God, I'm tired already. How are you guys listening to me? Address. URI, right? And we're making this public and we're saying uint 256 token ID is equals to token ID counter. So every time we mint, we increase the token ID counter by plus, then we add the owners of that particular token ID as to address, and then we say balances 2 plus equals to 1, token URI is token ID is URI, and then we emit transfer address 0 to token ID. Okay, great. This is simple. Come on. Emits a transfer with 0 address, which signals minting. That is why we're doing address 0. Right now, quickly we're going to write the token URI and then see how we're going to run the entire thing. Okay, so function token URI, we're saying uint 256 token ID, then we say public view returns what string memory. Okay, we're saying require to check, right? If the owner token ID not equals to 0, great. Otherwise, the token does not exist. Yeah, understandable. And then we return the token URIs of the particular token ID. So this is how you get the metadata URL for a given NFT, which is image, description, etc. Now, one thing is why this function design pattern. So if you're wondering why this contract has so many functions, some public, some internal, some that look almost the same, it's not over engineering. It's just a very smart separation of responsibilities. The idea is to break down things to such small predictable building blocks that each one does one thing well. Public functions like transfer from, safe transfer from, handle permission checks and external inputs, whereas internal functions like underscore transfer or underscore safe transfer do the core logic of moving tokens or updating the state. Any helper functions like underscore is approved or owner keep our access rules clean and reusable. And this modular structure is basically making the contract easier to understand, safer to maintain, and way less error prone. So especially when you start building on top of it with more complex features, think of assembling like Lego. Each brick has a specific shape, purpose, but when you snap them together, you get a solid, complete NFT engine. Now, for this to actually work, make sure you've got some MetaMask wallet with some test ETH on a testnet like Sepolia or an L2 testnet, and then Remix ID, and an account on Pinata. So what happens here is Okay, so I had to change my tab because my test deployment MetaMask is in a different account altogether. So we'll quickly compile. Now, one mistake that I was doing here is it was showing earlier that it should be declared memory or whatsoever. So this is bytes 4. Okay, so once you compile, it gets compiled. Now, what happens is that here you have to take it as injected provider MetaMask, and this is a kind of pop-up that you will get, and then you can just connect it. Right now, I think all I have is okay. Okay, so yeah, I mean, I was experimenting with the rootstock, so whatever. Yeah, so there's a toggle button called Show Testnet Network. So once you show testnet, there is a Sepolia testnet section. So you switch there. I already have 0.007 Sepolia ETH. So make sure you have some Sepolia ETH to be able to perform. Yeah. So we'll just go simple NFT, NFT.sol, and then I will just give this. We're saying Web3 Compass. And then string would be just compass. Yeah. Now I will transact. Okay, so it says creation of simple NFT is pending. Here you will get a pop-up and it says, okay, confirm. Okay, it's still in pending. Now what you have to do is, while this happens, you can go to Pinata, which is this app.pinata cloud IPFS file, and then you can just go do a file upload. I will do a just rename this web. Okay, so I'll just open it. Okay, upload. While this is uploading, let's see. Okay, so this creation of simple NFT was pending. Okay. I have already deployed it here, right? So I don't know why there is another pop-up. Okay. Now what happens is that once you've done this, you've uploaded it, it will give you IPFS hash, again, a CID. Now we have to copy this. Okay. Now, what happens is that since NFTs do not just store images, they store metadata that describes the NFT. This metadata is stored in a JSON file. So you have to create a JSON file like this on your local machine. Now, what I'll do is files nft.json. That there's a structure for this, right? And I'm saying that the name is going to be okay. Web3 Compass stamp. What? This is a stamp that we actually give out for completing courses and doing certain tasks. So then it says description, we're saying course 1 completed. Okay. Great. Fine. And then we say, hey, this image, right? I copied the CID, but how do I look at this? So yeah, this is how it's coming, right? Okay. So we've added this link. Now what we do is we will save this NFT.json. Okay, so the link format here is, I don't know, missing. So we'll change it to, like, you refer to the IPFS section. The Pinata, I don't know what it was trying to do. So I will just erase all of this and put this in this format. This is the same CID that we had here for Web3 Compass. Okay. And for the JSON, okay, so we've changed the link here. Now we created a JSON. We'll save this one, which we have saved as nft2.json, and then we will upload it here. Okay, and now there's a link for this one. Okay, I don't know why the image is coming. Let's copy this and go to Remix. Come back here. Okay. This is the wallet address. Let's just transact. There will be a MetaMask pop-up for the transaction to approve. I really hope that it shows up. Okay. So let me just confirm this. So it says transact to SimpleNFT is pending. Let's check on Etherscan. Okay. So for some reason, we're not able to see online, but then we go to testnet OpenSea.io. And just take contact. So Web3 Compass comes in items. Yeah, so you can see it, right? This was a test one. This is what we did. So this is how you're going to see it. You can check everything with the context and how many times we actually did it. You could see like 3, whatever. Details, contract address, token ID 3. This is the third one, ERC 721. Sepolia last updated 4 minutes ago. So just make sure that you're putting the right link here and then the JSON link, entire link here. Not make the same mistake that I did, that I was just putting the CID. Now, if you check name, symbol is still there. Can we check the balance of here? If we do the token URI, you get the entire thing. And then we can just use to do the transfers and all of that. Yeah, that's pretty much it. You learn to make your own token, and I will see you on day 22. Till then, keep building, guys.